I mean, feel free to jump in, but yeah, it should be fine.
Okay, Brendan, whenever you're ready, we can get started. We are recording this, so it will be available afterwards for folks who may join a little bit later, but go ahead.
Cool.
Let's
So
see the show.
Let's do it. Basically, what we're going to cover today, just a rundown on the database, what it's used for, why we have it, why it's unique, and then we'll kind of go through a couple of the tables, see what the schema is like, a couple of custom functions that we use to speed things up, a few query optimization tips, and then we'll jump into actually writing a little bit of SQL and see how it all works. So to backtrack, everybody knows about the API. That's usually what these hackathons use, is the Covalent API. And the magic of the API stands in the database, and the fact that we normalize all of the data coming in from all of the different chains that we index. So the schema is all the same across all the chains. So what that means is that we have an ingester pipeline, and it basically takes data from a data source, be it an RSK node, an Ethereum node, whatever it is, normalizes it and feeds it into our Postgres database. And then the API has templatized pre-packaged SQL that runs against the database, and it's all optimized for quick responses through the API. So the API is not built for data science or research questions. It's built to be used to build other products, right? That's usually what we do with 1 million wallets. But the database can be a fire hose if we want it to be, right? So we have these custom functions that we can tap into, and it's not built to be, user readable. It's not, all of the information is not stored as hex data. It's stored as, in various different forms, and we can use the custom functions to encode or decode that data. And I'll show you how to do that today. So for the purpose of, research or building these custom endpoints, the class B endpoints, and formulating the data in a way more custom for your project, that can also be what the SQL is for. And that's part of this stream, is actually building these templatized and pre-packaged SQL queries that we can then just funnel into class B endpoints. So there's kind of two objectives here. There's the class B endpoints, and then there's the more research dashboard, big data aspect. So it's a very one-of-a-kind database. There's not really anything like it in the market. Our founders, Ganesh and Levi, built a lot of custom patches and a lot of custom code to go into the database. There's no competitors really at this scale. And we have everything from every chain that we index. It's all there from the start to 2 blocks latency. So that's how fast it is. So depending on which chain, the database will always be 2 blocks behind, and depending on the chain, you'll see the time difference there. So Ethereum, it's about 15 seconds per block, so 30 seconds behind. I'm not sure what RSK, the block speed of RSK, but regardless, it'll be 2 blocks behind.
30 seconds, so
30 seconds, so there you go. It'll be a minute behind in the database, which is perfectly fine for most cases. And this is really why we're called Covalent. So bonding the blockchains and databases. And we essentially, through this database, we provide SQL interface to the blockchain. That's what this is all about. So let's jump in here. And I'm going to share my screen. And we can actually dive right into the client that I use, which is DataGrip. You can use any Postgres client, it doesn't matter. And I'll show a few other options later on, but let's just start exploring and seeing what's up in the database. So there's really going to be three main tables that you're after. The blocks table, the block transactions table, and the block log events table. There's other tables, feel free to explore them, but these are the three heavy hitters. So that's what we're going to cover. And then for RSK, it'll just be, chain RSK mainnet. You can change this to be chain RSK testnet, and it'll work just fine. So we'll just stick to the mainnet for now. And similar, you can change this to, chain ETH mainnet, BSC, whatever, any of the other chains. And the schema stays the same. So the query essentially stays the same. You just change the from clause, whether you're going from RSK mainnet to testnet to other chains. So let's just check out what this looks like here. We'll run the first command, and this is a look at the blocks table. So you get this ID, the block ID. That's basically a custom Snowflake ID. It's not super important except for optimization. It's a unique ID for each transaction. So that's when we join, that's what we want to join on, not on transaction hash, but that'll come up later. So we have ID, hash, signed at, parent hash, height, uncles, extra data, the miner, the mining cost, gas limit, gas used. All of these are pretty standard, and you can actually see them. If I go here, the RSK Explorer, let's just click on one of these transactions. You can see most of the names line up, right? Gas used, gas price, and you can get into more of the data. So most of the time, the names will line up with exactly what you see on the Explorer. So let's check out the block transactions table. And so actually, just to summarize this blocks table, essentially what it'll give you is an ID, a hash, the date, and the most important parts here would be like the miner, the mining cost, the gas used, etc. So now if we look at the transactions table, this will go a bit deeper. So you'll see the same ID field, or the block ID field here. The offset, the hash. Notice this isn't a hash, like I mentioned before. This is actually, we have to encode this into be a hash, and I'll show you how to do that in a second. It's stored more efficiently. So then we see successful mining cost from to. So similar information, but now we get this from and the to kind of overview with the value field. That's going to be a common one you use. The gas offered, gas spent, and gas price. Now these are like some of the first blocks because I just limited it to 10. So there's not a lot of data in them right now, but when we get playing around with it, it'll make more sense. So to summarize this block transactions table, it's basically this transaction level information. If we go on the Explorer, for any Explorer, it's the transaction level information. So if you go into the logs, the transactions table will not have any information on that. But that is a perfect segue into the block log events table, which is, if we run this, we can see, here's the same.
Brandon,
go ahead.
I've got a question. When you just specify select limit 10, does that always get you the most recent 10, like it's auto sorted?
No, it should. I mean, it's not necessarily sorted.
Right.
It just, that's just what it's giving me, the first 10 here. Yeah.
Yeah,
it's
so
not necessarily sorted.
So you've got to put more where clauses to get the most recent.
Exactly. Blocks. We'll get into that. Yeah.
Okay.
Where usually I'll do something like this, where the date is between these two ranges. That's usually what I'll do. Yeah. But for the purpose of this is just to explore the, what is available to us, and then we'll start to focus in a bit later on. So in this log events table, we have the same ID field, which is the most efficient field to join if you ever need to join these three tables. And I'll tell you the one main use case that I use it for and joining these tables when we get to the end. So log offset, that'll be in your Explorer. The block height that this block or that this transaction occurs at, the time, transaction hash, the transaction offset, different than the log offset, the sender, so what contract is emitting this event essentially. So if it's a transfer event, then it will be emitted by whichever token is completing the transfer. The topics field, which is actually an array, a tuple actually, I think it is. And I'll show you how to access that. So if there's multiple topics, let's just give a good example here so we all understand. Let me find one. Here we go. This one has 2 logs. So let me see what's going on here. So here we go. This log event has multiple topics, right? Multiple indexed topics, and they will all appear in this one field, and we'll have to parse them out. That'll be easy. I'll show you how to do it in a second. Same thing with the data field, right? You can have multiple different, this is just like a blob. So we have to parse that out as well, which we will do in a second. And notice how there's no gas information on these log events, because you know, log events, you don't necessarily associate a log event with gas. The gas is for the entire transaction, not for one log event. But if you're, you know, filtering on a topic hash, which we'll see later on, for like governance or something, and it's mostly just a governance transaction, and there's the one log event, and you want to see, you know, for these governance transactions, how much gas are they using? So you'll have to join the log events table on the transactions table. You might not have to, but that's one way to do it, is to join the two together. And you would want to do that, you know, instinctively you say join it on the hash, but it's actually more efficient to join it on the block ID. That's just one optimization that I want to point out. So now, unless there's any extra questions here, Brendan, then I'm going to jump into a couple of examples.
Cool.
So remember, when I do these examples here, this entire setup is used to power the API. So we have these, you know, these binary fields here, and there's terabytes of data stored in the hot RAM, which means we can query it very quickly for the API. And that's why it's stored in this form and it's not stored as a hex. So everything is meant for API query speed and not for human usability. So we've written some custom functions to help with this, and it works out because it makes the queries so much faster, and they're really simple to use. So the first thing we're going to look at is actually pulling information from the block transactions table. So to start, let me just get rid of some of this. I'm actually going to keep it though. Let's see what this looks like without the encoding. And so let me just remove all this. It's probably faster if I just write it, honestly, but it's fine. All right. Definitely need to put the commas back. There we go. So let's run this, and then I'll explain it as it runs. It should be pretty fast. We're going to select the truncated date. So notice in our date field, we actually have minutes, seconds, milliseconds. So, but let's just truncate it to the day, and that's going to be our date, the date that this transaction occurred. We're going to pull out the hash, the from, and the to addresses. So that's what we get here. If I pull this up, the date, the hash, from, and the to. There you go. But the hash, the from, and the to are all binary. We don't want that. So that's where we come with the encode right here. You see how I encode it as a hex. Simple custom query, very simple. So let's just open this back up, and let me explain this 0x part in a moment. So I'll just run it and show what this looks like here. So same thing, we're going to select the truncated date from the signed.at column. We're going to encode the transaction hash as hex, and then we're going to do the same thing to the from and the to. And here you go. You'll notice there's no 0x on the front of the transaction hash because I removed this 0x with the pipes. So do that, and then it'll look exactly the same as it looks on your Explorer, and we are all happy. So transaction hash from, you can just copy this, go to the Explorer, and we can see what we're looking at. I'm gonna actually just speed through this part a little bit. Let's just confirm. So from the null address to this 8, ending in 8. And in fact, that's what we see here. So there you go, confirmed. And then all I did was I looked at the date range of September 25th to September 30th. And you just do a simple where clause to do that. You can get way more complex with your where clauses and say, you know, where the from address is this, and you can see all the transactions with this from address. Where the to address is specified, you can see all of those on a certain date. You can get very, very creative with your where clauses. So that's selecting info from the transactions table. Let's I'll speed through this a little bit faster. We're going to select it from the log events table. Different information. So this time, you know, it all looks very similar. We're going to truncate the day. We could truncate this by hour, whatever. We could not truncate it at all if we want that granular of data. Typically, I'll truncate it by day so that I can do a daily group by, which is, you know, then I can see daily level data as it changes day by day. But I'll select the date, the block height. Block height is stored regularly, so I don't actually have to transform it at all. And then we'll do the same encoding on the transaction hash, the same encoding on the sender, same encoding on the topic. And then we'll get this new one here, which is ABI field. So what we're doing with this is accessing that data array. So if you remember previously, the data field is actually an array. And if we look back at our logs, just look at one of these. Nope, that one has multiple, so that's a bad example. Either way, there's multiple fields in this, or there can be multiple fields in this data blob. So to do that, we would say ABI field data and then specify the position. So this is position 0, position 1, position 2. It changes based on the topic hash. And it's very similar with the topics column, except we just use the square bracket index there. So, and the one thing to note that's a little bit annoying and confusing, topics, the first field is, you say topics 1. So that's always the topic hash is the topics 1, and then topics 2, topics 3, and so on will be the next in line. So this is the topic hash, which is the first one, which is topic 1. But annoyingly, the data field starts at 0. So just one thing to note. And then we're just going to cast this data field as numeric because it will also be stored as binary. If the data field contains an address, which it looks like these ones would, I just randomly casted it as numeric to show this example. But if the data field, you know, if we change this to data 1, and we knew that based on the topic hash, data 1 is an address, then we would just encode it. We wouldn't cast it as a numeric, we would encode it. So pretty simple there. And then we do the same thing,
Hey,
just filter it by date. Yep.
Yeah, question. Could you explain the SQL functions that you're using here? So date trunc, ABI field, cast, etc.
Yeah, for sure.
Like,
so
which ones of those are specific to
date trunc
Covalent?
and cast are like, just look up Postgres date trunk, and Postgres cast. Those ones are straightforward. The encode and ABI field are custom functions. I didn't write them. I just know how to use them. And it's literally, this is the only way to use it. So you say encode, you put in the byte data here, which, you know, typically this transaction hash would be, binary, and then you encode it as hex. That's it. That's all I ever used this for.
Awesome. So
we should put out some documentation on it, but it is not out. So
yeah, so the encode and the ABI fields are the functions, are the ones that are custom, if you will,
exactly.
from Covalent.
Exactly.
And they are already defined in the database that's being exposed. We don't have to write them or import a SQL file or anything. Awesome.
Correct. Yeah. So, and you can see the documentation here. Just hover over it. You'll see ABI field. You get your binary data, and then give an integer for which location you want to access, and it'll return whatever that is, and then you have to either cast it or encode it depending on what you're after. And I did type this up in a little attachment, so that'll get sent off as well. And we will document this in the future, but this is the first time we're opening this up to multiple users, so we're just going to see what happens here.
Yeah, awesome. Yeah,
any other points? I'm going to get a bit more fun and simple. It's going to be more simple going forward. So this is just playing around with the tables. Let me check the time. Okay, we're good on time still. So this is just playing with the tables. Now let's do a little bit of analysis here and see, you know, how I would go through this. So the question that Harish actually asked me the other day was, you know, how easy is it to look at sovereign governance data? So what I did, just come, let me get this Zoom thing out of the way here. I don't know if you can see it, but it's annoying me. So come here, I just search sovereign and there's also, they post all their addresses and everything, but I'm just gonna choose a random one for this example. Look, Governor Alpha, there's two of them. You should look into the difference between them. I don't know off the top of my head. I'm just gonna choose a random one. It's not important for this exercise. But what we're going to do is grab this address, and we're going to go over to the Covalent docs, the knowledge base, go to developer tools, the SQL generator here, click into that, make sure we select RSK mainnet. Let's put in that address, and this will work for any address that we have the ABI field for. If it doesn't work, send us a message and we'll ingest the ABI. Everything will be fine. It'll be immediately available. So these are all of the possible topics emitted by this Governor Alpha contract, right? All of the events. So if I go back here, and it actually writes the SQL for you, and then you can just modify it based on what you're after. So the topics: vote cast. It'll tell you the address of the voter, the proposal ID, Boolean support field, and then the integer of votes. There's also proposal queued, executed, created, and that's it for this contract. But you can literally enter, you know, whatever contract you want, address you want in here, choose the chain, hit go, and then you can grab the SQL for whichever topic you're trying to look at. So the one I grabbed here is just the vote cast. So let's get a look at this vote cast event. Back to my editor here. So this is all it is here. Sometimes there will be like a little error here with like an extra comma or whatever. It'll throw an issue. Just remove the comma. It's fine. So let's see what this is. So we're going to pull out block signed at, which is, we know from before, is our date. Pull out the block height. Okay, that we want that. We're going to encode the transaction hash. So we're pulling the transaction hash. We are going to pull out our ABI data field in position 0. This is a new one that I want to mention now, is the extract address function. Basically, it just removes padded zeros. That's all it'll do. So because we're dealing with blockchain data, you know, when we go back here, let me see if I can find an example. I should have pulled one up beforehand. Let's go events. There will be a bunch of random zeros beforehand. I can't remember the exact number. But if there are in a log event, where give me one of these transactions here. Event. Log. Yeah, okay, this is good enough example. So all of these leading zeros, we don't necessarily want. We want it to be in an address format. So that's all of this extract address does. If we remove it, and feel free to play around with this, adding and removing and see what it does, it's very clear. It just removes the padded zeros. That's it. And then we're going to encode it as hex, and that's the voter address. And then we're going to go in the ABI field again, grab the proposal ID, which is position 1. Position 2 is the support. Position 3 is the votes. This matches exactly with what we see in the explanation here. So cool, that makes sense. That's another way, if you're writing your own, just find the ABI for what you're looking at, and you know, use the information here to write your SQL. But honestly, I use this topic calculator for most of what I do. Just put the address in, grab the event, and then now we get to modifying it. You know, we can specify a date range, we can specify whatever we want, and we can optimize it however we want. So let me just run it as is. This is exactly how it was from that generator. And let's see how it looks. So we have block signed out, that looks fine. Block height looks fine. Transaction hash is encoded. The voter address has no padded zeros, and it's encoded, or it's sorry. Proposal ID, support are numbers, and the votes are fine. So the votes field this to me looks like it is scaled up. So there's no floating point on blockchain. So everything is multiplied by 10 to the 18, 10 to the 6, 10 to the 8, whatever it might be. So you'll just have to dig into the contract, and let's see if we can figure it out here quickly. Really, all you'll do is let me see here. This feels like, oh, there it is, code. Okay, it's not. I'm not going to go through all that, but you can go on the GitHub and it'll tell you. It looks like 10 to the 18 to me, but just scale these numbers down by whatever the contract decimals are, and that'll be the last step so that you have to do. So it'll literally just be, let's just call it 10 to the 18 for now. Run that again. There you go. Might be more. I don't know. That's fine. So now say you want to do a date range. All you're going to do is say, and it's E, which is RSK mainnet block log events, dot, let's do date, block signed that is between 20, what, let me just see so I get something right here. 2021 -01 -01 and 2021 02/01. So this will pull everything in January 2021. Run that, and there you go. So you can filter on block heights, you can filter for a specific transaction hash, for a specific voter, for a range of voters. You know, you could just do this in function, all these SQL functions, right? And then you just say, you know, you have to have the address, blist voter 1, voter 2, etc. Whatever you want to do here, you can get very customized. So one thing to note here, though, let me go back to exactly how it was. This e.topics1 we are filtering for that topic hash, which we saw in right here. This is the topic hash because we're looking at the vote cast event. So notice there's no 0 on any of these, and the /, or I think that's /, whatever, the slash denotes or converts it to binary. So what you could also do, I guess, if you want, is encode this side in, and then have them, I'll show it, then I don't have to talk about it. So we can do that, and then we can make this, what is it? This won't work because of that. So anyways, I don't want to mess this up. So let's just leave it as this. Remove the 0, put the slash, your life will be easy. But the faster way to do this when you get a heavier query is actually to search. If you remember, that topics field is an array. So first, this operator right here just means contains array, the topic that we're after, and then encode it binary, boom. This will be a lot faster. And then if you're particular about a specific location, so say this was an address that you're looking for rather than a topic hash, the topic hash will always be in the first location. So you don't actually need to specify topic 1 afterwards. But if you're looking for an address in the topics field, it's fastest to, and then actually put this first above the sender, because then it'll search through all the topics fields. It'll be a lot quicker. You'll see, and play around with this, but you'll see improved query time if you do the topics first and you say, use this contains array function, which I've documented this in the email that we're going to send out afterwards. So don't worry about it if it doesn't make perfect sense right now. But I've optimized this third example. So we have our topics contains this topic hash. And then we can also confirm that topic 1 is the topic hash. And this query path will be a lot more efficient than the previous one. That's just one optimization note that you'll want to know about. And that's the only difference between the previous one and the optimized one, is that, and for this one, it's only a very small number of events. So it doesn't make a massive difference, but it's still like half a second difference just in 132 rows. So again, this contains array when you're searching on the topics field in the log events table will save your life for bigger queries. And like I mentioned previously, you can join to grab the gas info. So I didn't actually finish this query, and I'm not going to finish it here. I want to leave a bit of time for questions and a recap. But this is how you would join the transactions table with your log events table and pull out that gas information. Join it on block ID from the log events table and block ID from the transactions table. And then you can also do like a confirmation and say transaction hash is the same. But this will be a lot faster because the block IDs are unique snowflake IDs, whereas the transaction hashes are binary fields. So all of that done, let me jump over. I'm going to copy this to a dashboarding tool that I'm going to recommend you play around with for this hackathon. So you, like I said before, you can use any client, any Postgres client you want to play with all the data and everything. But you can also use Metabase. So let me just put this in here and run it. And then I will explain how we launch. You can basically run your own Metabase instance. So I just click this, deploy on Heroku, create a free account. it'll show you this page, give it a name, and literally all you have to do is hit deploy. And then it'll run all of these checks itself. You hit view, it'll bring you over to a setup page, enter your credentials that we will email you, and then you get to this screen here where you, after you just click the write SQL button on the top. It's as simple as that. So just to quick recap, go to the Metabase open source page, click on deploy to Heroku, make sure you have a free account. Notice all of this is free. Click deploy. In here, click deploy one more time, view, you're good. It'll open up a Metabase page, and then we can start playing around. And Metabase is actually what we use in the Research Guild as part of the Alchemist DAO. And if you're interested, the guild leader, Tommy, will be giving a talk on that immediately after this call. So let me see what's going on here. Permission denied for schema. Oh, I entered my credentials wrong. I was doing this in a hurry. So what I'm going to do instead is just go to the regular one. So I just set this up this morning and I must have entered my credentials wrong because permission denied. So shouldn't have that problem. And if you do, just message me and we will fix it. But this is the Alpha Alarm one, which again, I'm not going to give an intro on it because Tommy is going to give an intro on it later. But let's just put this in here and run it. And there we go. So same result in the Metabase browser. But what we can do now is make visualizations out of it, right? So let's just see what we have here. Actually, rather than making a visualization, I'll just show you some of the ones we've previously made, just probably one or two, but you have all of these visualization options, and then you can get into like custom setting options for formatting and everything. And then you can get some, final products. We haven't finished this RSK one yet, which we will soon. So then I wanted to show that one, but let me just show like Aave or something. Here we go. So then you can get dashboards that look like this. They obviously are live. They take a second to load, but this can all be done on your free Metabase Heroku instance. And then if you upgrade to like a free or a, I don't know, $2 a month trial or whatever, then you can get better performance, whatever. It's up to you. I think for the hackathon, we just want to see the results here, and then we can worry about how it's deployed later on. So what we can do here, and what's nice if you're interested in joining the guild, is that you can just click in to any of these, and then I can see the SQL that somebody else wrote here. It was actually me that wrote this, but if it was somebody else, that I could see it and learn about it, understand it better. You can change all the settings. So all of this can be done in Metabase with the RSK data that you are searching for. All right, going very fast. So I'm going to loop back around and do a quick recap. So we started with just a simple 3 tables: the blocks tables, the block transactions tables, and the block log events tables. The blocks table basically just tells you very high level, what's the hash, when was the transaction signed, who is the miner, what's the height, what was the mining cost, etc. Second table is that block transactions table. And this tells you a bit more granular information, but still an overview. So you'll get the block ID, the transaction hash, the from, to, and then the signers, the signed at, etc. And the block log events table, the final one, and to me, the most powerful one, because we can actually get into the nitty gritty of the events. We'll show you that same block ID, the block height, the date, the hash, which remember, this is binary. So you have to encode it using that encode function that we talked about. You get the offset, the sender, which is also binary, so you need to encode it. The topics, which is tuple, so you need to specify the position. The data, which is an array, a binary array, so you need to use the ABI field function to specify the position in the array. And then you need to encode that as hex or cast it as numeric, depending on what type of data the specific index you are selecting is. So that is a recap of the database. And then the tools that we talked about, just the basic Explorer. I'll do a lot of clicking around and searching in the basic Explorer, confirm that what I'm looking at in the database is correct compared to what the Explorer says. And then after that, we looked at this topic calculator, the SQL edition. There's also a basic topic calculator that you can check out if you want to say write your own. If you're practicing, you can take that address, put it in here. Let's just do it. And then I take the address, put it in here, select RSK mainnet, say get events, and it'll just give you the voter, the proposal ID. It'll give you the structure. You can write your own SQL based off of this. And then you can confirm it by using the calculator. That's a good way to practice if you're keen on doing that. But if you're just trying to get results, then go here, copy this SQL, make sure it works, optimize it to your liking, filter using the where clause, join using the from or on the from clause. And yeah, that is the end of the documentation. And then we go to Metabase. All you do is Google Metabase open source, click deploy to Heroku, sign in with your proper credentials, unlike me. Go to the top, click this write SQL button, select your replica, and get to dashboarding. And hopefully you come up with something cool. There's also the other challenges. They're not all dashboard SQL challenges. So definitely look at the challenges that have been posted. And yeah, hopefully I didn't go too fast. If I did, luckily this is recorded, so watch it again.
Yeah,
that's all
awesome.
I have. Any questions, concerns?
Yeah, just wanted to clarify maybe something that would be useful for participants. The SQL file that we're demoing from, that's included in the pack that will be sent afterwards.
Not the file, but the queries. Yeah, the queries.
The queries.
Have in a document that will be sent out. Yeah.
Yeah,
for sure.
And in Metabase, you can just select from a drop-down RSK replica as a data source. How do we get the credentials for that?
So we will be emailing out the credentials soon after this call, probably within an hour or so.
Awesome.
And everybody that has signed up will get their own credentials. So yes, we will be able to see, if anybody is misbehaving and crashing the database. Yeah. So then we'll just turn you off if you are. So be mindful of that. Like, you can run long queries, it's fine, but just don't crash everything. But yeah, everybody will get their own credentials. And you just sign in, like, it's very intuitive sign-in process. The same way you would create the connection on DataGrip or any other Postgres client, you do the exact same thing with Metabase. And the instructions on all of that are in the email as well.
Yeah, and just for asking on a question on behalf of those who haven't joined this session live, for those who are watching this on YouTube, for example, later on in the hackathon, if you don't have the credentials by email, how do we get them?
Yeah, so message in the Discord if we're slow, but basically sign up, you'll still be able to register, and then I will send you the credentials, or somebody will send you the credentials soon after you sign up. And if you're like really keen to get going, just drop a message in Discord. Harish might have a comment to add there for a better process, but yeah.
Yeah, so through the registration process, if you select that you're participating in the SQL stream, we're tracking who's signing up for that particular stream, and we're sending out credentials accordingly.
Yeah.
Great.
Cool. Any questions from in the comments here? No. Looks fine. QA. I think we're all good.
Awesome. This was great, Brendan. Thanks so much for walking through. I know there was a lot of content that you covered in a short amount of time. So there will be a recording that we'll be putting on YouTube shortly here. And the link to that will be in the email that gets sent out to those who we've got recorded as taking part in the stream. And so you'll get your credentials. As Brendan mentioned, if you didn't receive that email, please reach out on Discord, or preferably go to the website and register. Yeah, if you want to melt the database, maybe don't do it too excessively. We do want to use this for future hackathons. And yeah, this is super exciting. First time we're piloting this, and really excited to see what folks can build. Highly recommend you look and use Metabase. It's so quick and so easy to deploy it on Heroku, get your own instance, and especially to create the visualizations. It's just a few clicks, and it's just so seamless. So definitely recommend you take that approach if you're considering different tooling or editors to use.
Yeah, you can also, just to add on that, you can also use Tableau or Power BI or whatever. It's just a Postgres client. But yeah, Metabase, if you don't have any preference, Metabase is quick and easy. But if you do have a preference, then it's just Postgres. So you can use whatever you want, really. And then just before we wrap up, I want to plug the Research Guild. So part of the Alchemist DAO. We made that Metabase page, the Alpha Alarm Metabase page. We're still working on it, still building out a bunch of dashboards, and we're actually looking for help. So if you find this SQL stream is enjoyable and you want to do more work and more research on RSK or any of the other chains, then just go check out the Alchemist DAO Discord and message us for the Research Guild. We are always looking for good talent.
Great. I actually do have one more question, not directly to do with this SQL presentation, but more to do with the tool that you use, Topic Calculator SQL.
Yep.
So if you have a contract that is currently not registered, if you will, with the address for this ABI, is there a form for you to say, I want this to get indexed and submit the ABI? Is that done by Discord, or is there a form for that?
Well,
go ahead, Harish.
You go ahead. Let's see if we got the same answer.
I was going to say, just to be clear, it's already indexed, meaning we already have it. There's no wait period or anything. We just need to decode it, which means we need to upload the ABI. So
right.
You'll be able to, like, all of that information is already available everywhere. So you can, like, there's no hindrance. It's just it's a simplicity or error, not error, I guess, but it's an annoyance, but you can still find all that information, and then the data is in the database. That's my point here. So you can just type it up and it'll all be fine. It just won't automatically generate the SQL for you. So yes, just message on Discord and we will create a process. I think we are creating a process, and this is where Harish can step in. But my main point there is that it's not going to be a big hindrance for you if, like, don't freak out, just go and find that ABI. Let us know, but you can see the ABI yourself and the data is already there. So just look at the ABI and write it out that way.
Okay, so I guess sorry. I guess just to follow on. So just to clarify, the ABI field custom function that that relies on it, the ABI being uploaded, but pretty much everything else is already there.
No. So the ABI field SQL function doesn't rely on the ABI being uploaded. Just the topic calculator, like the decoding of the topic calculator, relies on that. Right. So if you already have the structure for that event from the ABI field that you found yourself that we haven't uploaded, you can still you can see that position 0 for a transfer, or position 1 for a transfer event is the I don't remember, the from address or whatever. You can see that, and then you can go in the database. The data is all there. It's just not decoded on the topic calculator. That's all. That's it.
Cool.
And then to your other point, Brennan, I've just finished putting together a quick type form. So we will include that both in the event calendar under this. It will be part of the email that goes out, and we'll also make sure it's pinned in our Discord so people can use that to quickly highlight which ABI they would like uploaded, and it's really quick on our end to do that.
Awesome.
Yep. Awesome. Well, just reach out in Discord if anybody has questions. Let's get going. Let's get building. I'm excited to see what happens here.
Sweet.
Okay, Brandon, thank you so much. Really appreciate going through this. We'll have, again, the recording for this will be put on YouTube shortly here. And if you haven't already registered and mentioned that you want to be part of the SQL stream, please do so from 1millionwallets.com/RSK. And we will then be able to send you the credentials to actually access the database.
Awesome.
All right.
Yeah, thanks everyone for attending. Yeah,
yeah,
for sure.